In this video, we solve 6 problems using the product rule for derivatives. Before we get into that, let's have a quick brush up on the product rule itself. We have two functions, u and v, that are multiplied together, and we take the derivative according to this rule. The derivative of the first function times the second function is given as derivative of the first times the second plus the first times the derivative of the second. We can also think of this as u prime v plus u v prime for short, and sometimes I use that notation here to save time. In more detailed notation is the primes notation, in which we have the derivative of f times g, again f prime g, f g prime, derivative of the first times the second function plus the first function times the derivative of the second. The reason that the product rule looks the way that it does has to do with the definition of derivative that I'll talk about in a separate video. Here, let's just point something out. It is not true that we can say that the derivative of a product is the product of the derivatives. And we can see that why not, even for very simple functions such as these two. If I take f times g, I get x to the 5, and derivative of that is 5x to the 4th. And on the other hand, if I take the derivative of f, that's 2x, derivative of g is 3x squared, and the result is 2 times 3, 6x cubed. And we see that 6x cubed, of course, not equal to 5x to the 4th. There are functions f and g that give us equality here, and I'll talk about that also in a separate video. Alright, now let's solve some problems using the product rule. The first problem is x squared sine x. We want to take the derivative of that. Let's call one of these two functions u, it doesn't matter which, and then the other is v. According to the product rule, we take the derivative of the first, derivative of u, times v sine x, plus the first function u times the derivative of the second function. Derivative of sine x is cosine x, so that's v prime. If I pull out a common x from this expression, I'll get a more compact answer. Problem 2 involves the product of this polynomial times the exponential function. To take the derivative, we call one of them u, let's say like this, and v. Then the product rule says take u prime, derivative of x cubed is 3x squared, plus derivative of x1 times e to the x v, plus u times the derivative of e to the x. Derivative of e to the x is itself. Here we can also factor out a common e to the x and collect terms to get a more compact answer. In the third problem, we want to find the second derivative of this function. Remember that the second derivative means we take a derivative of the derivative. So the second derivative of y is the first derivative of the first derivative, taken twice. We just talked about the first derivative in problem 2. We got this expression, so now we use the derivative again to find the second derivative. Let's call this first function u, and e to the x we call v, Um, derivative of u is 3x squared plus 3x squared times becomes 3 times 2x to the 1. Derivative of x is 1, derivative of 1 is 0, times e to the x, plus the first function times derivative of e to the x, which is itself. Once again, we can pull out a common e to the x and simplify by combining terms to get a simpler answer. In problem 4, we have a square root of x times sine of x. The product rule can be applied here. We think of x square root of x as x to the power 1/2, and call that u, maybe call the other function v. Derivative of x to the 1/2 u prime is a half x to the minus a half, that's just the power rule, times the second function plus the first function times the derivative of second, which is derivative of sine or cosine. Here, instead of leaving the answer like that, which is kind of a little bit messy, I'll simplify by writing the negative power as a positive power in the denominator, and then put square root for power 1/2 and get this answer for the problem. In problem 5, we want to find the derivative of natural log of x divided by x. It looks like this is a fraction which involves division, not a product, but if we take a closer look, we see that we can write ln of x over x as ln of x times 1 over x, and 1 over x is the negative 1 power of x. So now we actually have a product, and we can apply the product rule to that. Let's call ln of x u, call x to the minus 1v, and we get derivative of ln of x u prime is 1 over x times v, the second function, plus the first function ln of x times the derivative of the second function. Derivative of x to the minus 1 is minus 1x to the minus 2. Okay, again, rather than leaving the answer in a kind of a messy form like this, I'll change the negative powers to positive. I'll get x to the minus 1, 1 over x, and x to the minus 2 is 1 over x squared. I put the negative sign up here. 1 over x times itself is 1 over x squared. ln of x times 1 is ln of x over x squared. I can combine the fractions and get a very simple final answer. In our sixth and final problem, we are taking the derivative of this function here. Once again, we can remove the fraction and write this up as the product of 3 functions. By the way, suffice it to mention that this problem, just like the previous one, can also be done using quotient rule, but it's not significant enough a quotient to really worry about it. We can do it either way just as easily. We have 3 functions, and we can take the derivative using the product rule by pairing functions 2 at a time. For example, I could pair these 2, and then I have 1 pair times the third, or I can do what I've done here, pair the second 2, call that v, call the first one u, and use the product rule on these 2, mainly because I've done this derivative here in the previous problem. Using product rule, the derivative of this function is u prime, the derivative of cosine, negative sine, times v, plus u cosine itself times the derivative of v. This is v prime. I have written it like this, and we see that I have a product of two functions, and we did this derivative in problem 5. This or this, when you compactify it like that, came out to be this expression, and now I can combine these two to get a single fraction for an answer. In order to combine, I just multiply by x, and that divide by x to get x squared at the bottom. With x squared is the same, I can combine the fraction x times sine x times ln x plus this times cosine x, and that's our final answer.